The material that we've been looking into is we've been using as a carbon negative core for a facade panel for a affordable housing project in West Oakland, California. It's a type of mycelium composite.
Nice. Now you're getting me interested. But why mycelium?
Yeah, that's a good question.
Aren't those mushrooms, by the way?
Yeah,
It's a
type of mushrooms.
it's a part of a fungus, so it's like mushrooms are one part and mycelium's another part.
Welcome to another episode of the Most Modern Podcast, where we establish convening power in the built environment. This season is all about research, and with us today is a very special guest, Brian Lee, who is a principal research scientist at Autodesk. Welcome, Brian.
Thanks, Lebo. Hey, everybody. Hey, Minku. Hey, Alex.
Hello.
Hey, Brian.
Brian, so as we know, you are a principal research scientist at Autodesk, but it's a company most well known for selling CAD software to architects, engineers, and special effects studios. Can you tell us a little bit about your background and what led you to this role?
Sure. My background is in architecture. I went to Columbia University, and I'm originally from Arizona. So I moved here for school and ended up at WeWork in 2015, where
another alum of WeWork, yes.
this WeWork alum network that's very important. So I was in the construction research team at WeWork for 4 years, and that sort of role shifted around a bit. So I got into the AEC research kind of domain during that time. Focusing on construction optimization type workflows, going from design to manufacturing, and it was very exciting because as you know, like WeWork tried to own the whole supply chain in a lot of ways, or deliver from design to delivery. So we got to get very involved in the design component and also the manufacturing and installation component, so we could build these workflows from end to end. And then after being there for 4 years, I left in 2019. I went to work for one of the manufacturers actually that I had been working closely with while I was there. We've been designing some wall system products. When I was there, it was funny. I was like the wall guy because we built these like automation tools that like took these basic Revit walls and just made kind of like convert them to like a fabrication level model, and then helped you or output all of the fabrication and construction data that would go to the machines, and then the machines would produce all of the parts, and then those would like make drawings, and they would go to site and they would install it. And we had like this really close connection with everyone, from the designers, developers, the construction guys, the people on site, literally like training with people on site to read these new documents, and the manufacturers. Anyways, so we got really close with the manufacturer, so it made sense. It was like a kind of cool, a very interesting transition. And so I ended up working there for 2 years. It was very exciting because I worked directly for a manufacturer. There's a whole different set of problems, a similar familiar area, but I got to get farther into the manufacturing space. But I was still doing some of that kind of work, and designing new systems that could be reconfigurable and like sort of demountable type furniture wall systems that could be reused. And that was the thing that I was most interested in at the time at WeWork, was how can we design these systems to be just like stop throwing away this stuff. Mm-hmm. It's Have you been to? You've of course been to WeWorks, I assume.
I've definitely been to a few WeWorks in my day, and yeah, you notice how modular everything is, and especially when you go to a WeWork in one side of the country and then to one in the other side of the country. But that's sort of like the remarkable thing about it. It seems like magic in that regard. Maybe the snake ended up eating its tail, but at least from the outside at the time, it looked pretty cool.
It was very exciting to do that, to like figure out the system, to like roll all of that out and see it physically happen.
Yeah,
And
maybe one thing we could talk about. I remember when we were working there, there was that one GIF that you made that was on every article that WeWork would put out about what we were doing in terms of like construction and research and development. And I guess can you tell us a little bit about the impact of research at that time? Because it links together so many different things that used to be done piecemeal. I don't think people quite grasp just how much time and effort and even mistakes is saved by being able to go directly from a Revit model to manufactured components.
yeah, for sure. Classic issue of silos in the construction industry. It saves an enormous amount of time, right? Whenever we brought somebody on that was new, such as like a new installer or construction firm that became part of the WeWork machine, they were just like kind of blown away by the like speed of the process and like how quickly they could get going and connect with other aspects of the organization that where they need to get approval from, or how we were building those workflows with kind of somewhat seamless, but standardized ways to share data and to create continuity through the whole process.
But maybe I would just want to ask you a question here. Is this a thread that you feel like got started for you personally at WeWork, but also maybe in the industry? Because I think of WeWork as the first sort of tech building company, or at least the one that was the most successful up to a certain point. And that sort of innovation and that you say is powered by the research, I'm wondering if that has continued onward for an industry that is known for very little innovation, so to speak, and that sort of research, as you mentioned, directly drives the bottom line. The more efficient things are, the more profit can occur. Is that a shift that occurred in your career and maybe broadly in the industry?
Yeah, I mean, I think that in the industry now is a huge shift, like everything being, trying to have a single platform, cloud platform for manufacturing data, for example, or in construction data, that it's all the same, is a enormous challenge to try and integrate the needs of all these different industries into this single source of data, common shared data. And the values huge, yeah, from a bottom line perspective, for sure. How much time and effort is spent coordinating and fixing mistakes and duplicating efforts for whatever reason, liability, contracts, because you just don't have the information, so you just have to do it, or standards, those kinds of things.
And we've talked to others, and Lebo, of course, has shared his background at WeWork too. But part of what stands out to me is that WeWork and also Autodesk are not working for as service providers like the standard AEC industry player. They're not an architect, they're not a contractor, but they have a product that they can then research, iterate, and then kind of continue to develop. I think that's probably a pretty important component of what you do, and probably how your career has tracked across these different companies too, I would assume.
I mean, like personally, kind of. I love buildings, I love architecture, I love construction, and as soon as I got out of school and learned that there's this other stuff that I could do, that's way more that was way more exciting to me than just working at a traditional architecture firm. Mm-hmm. I just went off on that tangent, and it's been for me very meaningful. I mean, in that you could see that you can make a lot of impact, or you hope that you can, and you're just like on that kind of more long-term journey that your work is having some kind of impact and is meaningful. I think for me, it's more around like the sustainability and the climate component. Some of the stuff I was doing at WeWork originally was like, I want to like make this reusable. I want to make all this stuff like reusable and reconfigurable. And it wasn't originally because I was like, because it's really sustainable. It's just like, this is more, it just makes a lot more sense. Look at all this valuable material that we could reuse and reconfigure. Like if you see how a lot of commercial real estate operates, you already know, like they just everything just gets thrown out because on the balance sheet it's just already, not it doesn't have any more value, or it's cheaper to get rid of it. So
Maybe we can cover a little bit on like what the role of research is at Autodesk, because you're a researcher at WeWork, which was kind of this vertically integrated product company. You're a researcher at a manufacturing company where you were working on maybe like standards and components. But Autodesk is a software company, and they don't actually build anything, right? Like buildings are not their product. Their product is something to help others build buildings. So what's different about research at Autodesk? Can you give us a little bit of insight on what role research plays?
yeah, sure. Well, it's pretty different in some ways. So we were, working for previously a company that was making this physical product and working toward that one goal. But now, like at Autodesk Research, we're helping make the products and tools that are for industries that design and makes everything. It's much more broad. So you have architecture, engineering, construction, and even the media and entertainment world. So the exciting thing about that is that things that you work on can scale up and have a much broader impact. Those tools and things that we use, are being used so widely in the industry, and Autodesk is a huge player in that space, in the space of software for these industries. Autodesk Research is covering a lot of these different industries, and the one that I am focusing on particularly is the AEC industry, and with an even more narrow focus on sustainability and net zero buildings, helping enable people to design and make more sustainable buildings, but also even more focused on low carbon materials. One of the biggest challenges that we are mentioning is using new materials, the kinds of materials that will help us make or reduce the carbon footprint of buildings.
So sustainability, I think, is a pretty popular topic, and I think it's something that we're trying to tee up for the next season of this podcast. But I guess why specifically materials? Like, what makes materials the right area to make an impact?
Materials are they're super important. Like if you look, it's everything around us, and everything that is around us was made with some form of energy, or with materials that are derived from potentially fossil fuels or something that emitted greenhouse gases in the process of its production. Buildings are one of the most carbon emitting industry, or the building industry is one of the most carbon emitting industries globally, and materials make up a significant component of that. It's around globally 11% or so, depending on the source that you look at. So it's a humongous little. It's a chunk of the pie that, if you compare it to other industries, is enormous. So there's an opportunity and a kind of desperate need to solve that. Yeah. So
Yeah.
I mean, there's a lot of reasons, but I mean, that's all I'll say.
It's interesting though, because when I think about materials, selecting them as an architect, you usually choose them on a few criteria. From the architect's standpoint, it's usually based on quality, and that can be assessed based on its visual quality, its aesthetic quality, or its performance quality. So how durable it is, how resistant it is to damage or needing to be maintained. And then if you're on the other side, the owner's side, maybe you're a little bit more concerned with its financial performance, how cheap it is. But never do we really consider, at least in my education, we never really considered the sustainable, or the kind of the sustainable performance of a material. So is that a gap that you're trying to fill, Brian, at Autodesk?
Yeah, it's the data on sustainability, or the gap on sustainability data is a big problem for the industry, for materials in general. That is a big focus, and especially for new materials. Not to even to mention like existing materials, like having enough information at the right time in the design process like that works, that's like in your workflow, the way that you currently do things.
When you say new materials, you mean emerging materials that are being developed right now?
Yeah. Yeah. So it's like, you use the materials that you currently use on projects because
Them
already the things
familiar.
about them.
Yeah.
Yeah. And like already everyone else does too. So it's, the process of doing it is like, you don't have time. You're not getting paid for that to do all that research.
So, Brian, we talked a lot about the context around research, all the things that go into it, its role at Autodesk, but we haven't yet got into what specifically you're researching. So, can you give us the layman's explanation of what your research is specifically about?
Yeah, so my research focuses specifically on enabling the use of low carbon materials in the AEC industry. And then by low carbon, I also want to include new materials and other kinds of reused materials. And we know that it's an enormous challenge for practitioners to make the decision to use a new material in a project. And we want to help them overcome that.
So are you measuring carbon from total sort of carbon input, including manufacturing, installation, and use afterwards?
Yeah, exactly. So there's a lot of ways that you measure carbon. Typically it's broken into a couple categories, like high level, right? It's like operational carbon, embodied carbon, and operational carbon being more about kinds of emissions related to its use and or the operation of the building, and embodied carbon being more about the emissions associated with the manufacturing of the material. And that we could stop there, but you can go another level and be like, where does that stop, like right at when it gets installed, or does it also include like what you were just mentioning, when it's in use, or when it gets maintained, or when it gets replaced, and then what happens at the end of the life? Like there's the ways that we have to track all of those different aspects, and talking about the whole carbon, the whole life of the product is super important in a really challenging area that we're thinking about. But the typical way that industry currently thinks about embodied carbon usually is the very front. It's when it gets installed. Even that, like before it gets installed, is even more.
Is there a specific material that you're focused?
So the material that we've been looking into is a kind of we've been using as a carbon negative core for a facade panel for a affordable housing project in West Oakland, California. As we got to make all the way to producing the kind of full scale prototype of this that will be installed in a real world project, and the journey to get to this point is now we've published in a series of blog posts that we hope that listeners to this podcast can go check out on the Autodesk research blog. So it's a 3-part series that's talking about the kind of more in-depth research that we were doing around this new material. It's a type of mycelium composite, which people may be also familiar with. And then its application in a building component, and in particular, a more high demand type of building component, a facade panel. And the journey of doing that kind of research, and how it ends up or will end up now being on a project, and the learnings that we've come away with.
Nice. Now you're getting me interested. But why mycelium?
Yeah, that's a good question.
Which are those mushrooms, by the way?
Yeah,
It's a
type of mushrooms.
it's a part of a fungus. So it's like mushrooms are one part and mycelium's another part. And so the mushrooms are the stuff that you go into the grocery store and eat and you see, right? Or in the forest and you point and you see growing out of the ground. But the mycelium's the part of the organism that is underneath the soil that you can't see. And that's like the main part of the organism, actually. And it's the thing that's, doing all of the decomposing and has the relationship with the other trees and tree roots. But anyways, it's fascinating material, and there's been a lot of research around mycelium composites over the last decade or so that's has been increasing, particularly as an alternative to a lot of synthetic materials like foam, EPS foam or polystyrene foam, and the reason why it made sense was kind of from another angle. It has unique properties that a lot of these synthetic materials don't have. It's not necessarily the mycelium really itself. It's just that mycelium is a fantastic natural binder of sorts. The process of manufacturing is very low energy, and it can utilize a lot of waste streams. One of the big components or it's a number of things. But one of the big components is that you're utilizing these waste streams and storing the carbon that would otherwise have been re-released back into the atmosphere. So, it can be a bunch of different organic materials that can be used for this, but the one that we used in particular we were working with a company in upstate New York called Ecovative, and we were using one of the materials is a byproduct of the hemp industry, and hemp is 2.5 times better at or faster at storing carbon than trees, as an example. So it's a way to lock carbon into a product and use its carbon negativity to help offset other components of products that it is a part of. And so in this case, it was a facade panel. And also there's other really important acoustic, fire resistant, and structural aspects of the material that make a lot of sense for this application.
Wow. So you're talking about, unlike foam, which are just used as insulation, and then there's a rain screen or another material to clad it, you're talking about more of a combined, like all-in-one type of facade material that can be just directly applied to whatever finishes the interior wall has.
Yeah. So in our case it's an exterior material. And it's kind of all in one. That was one of the really big reasons why it made so much sense, and also another reason why it's not so intuitive for the way that we currently build things, and is a good example of the gap that we were just talking about. The standards and building code regulations that we currently use to just quickly build and not think about those types of opportunities. It just excludes a lot of new materials like this and new systems. So, but how can you make it so that we can discover and implement new materials like this, but at some kind of scale? So thinking about that problem for the industry was super important.
So you're saying that the industry needs a sort of proof of concept, otherwise it's not going to budge. And is that maybe 100%. The role of research in this regard?
Yeah, 100%. That's a big, important role that we play. You can talk and talk and talk about good ideas, but you have to someone has to do it.
Yeah.
But and not just do it. You can do it yourself. That's that's one way to do it. But the way that I like to do it is with customers, with industry. It's you're challenging the real problems. You're not working on some problem that's not actually a problem.
You mean like what happened in other sorts of research institutions, like a university?
Yeah, or even you could hack happens everywhere. Yeah, but you know what I mean.
You definitely. It's really fascinating because I've been hearing about growing building blocks for a long time. I remember there was the MoMA PS1 competition years back, like a decade ago, where it was all about mushroom blocks. But I think you guys are taking a very professional approach to it and really serious about this since it's being implemented in a building. Can you talk a little bit about how your research at a kind of granular molecular level works in terms of making this mycelium a feasible building component?
Yeah, sure. That was like very big challenge to actually make this material suitable for the application of like a facade. There's a lot of examples previously of the material being used, as a kind of just a demonstration of the material itself, but not taking into account the kinds of requirements that you actually need from like a building regulation and compliance perspective, and the kind of structural and engineering
or to build
components.
However, a multi-story building, even,
Yeah, or to use it in a real building application, not just a demonstration either. So it's like you have to deal with determining the kinds of fire resistance of the material and how it's performing in with lab scale tests. You have to also meet the kinds of mechanical properties that is necessary for it to be under the kinds of real building loads, and that was actually the starting point. So once we figured out that, or realized that there's a potential to use this material that solves a bunch of different challenges. So one of them being, can we make this carbon negative or carbon neutral? It's like this material can store carbon and offset the carbon emitted by other components. That's a huge one. So then, can it fulfill the role of can it meet the fire resistance requirements for a facade? Can it potentially meet the moisture management kind of requirements that a facade is required to do? Does it have the durability that's required? Anyway, so starting with the mechanical properties was kind of the big one. It was like a lot of the application of the material is used in currently in a commercial application is for like packaging. Sort of more sustainable packaging alternative, but it's not strong enough to, for our application, be the core in a sandwich panel. That core has to transfer shear loads from the inside to the outside, from one side to the other of a sandwich panel, facade panel, and also withstand kinds of deflections and loads of wind. We've done a lot of material tests, varying a bunch of different parameters to see which ones were able to help it improve those properties. In some cases, adding additional ingredients or things to the material to provide more tensile strength, or that could contribute to its overall shear performance. But then in our case, a big part of it was increasing the density and the different growing conditions. And so we got to a point where we proved that this material could meet the same mechanical property requirements of the typical synthetic foam alternative. Prototype, we were working with the company Ecovative for them to develop a manufacturing method which could achieve those same mechanical properties, and so they were able to do that. The next step is, like, you have this part, for example, now you try and pass these larger building scale tests. So, for example, we did one of the large building scale tests, the E84 test, and it's for flame spread and smoke development. It's a test that they burn a 24-foot long test specimen in a chamber for 10 minutes. So they have like a fire at one end, and they're measuring with sensors all the way along on that chamber, and you get a score, and you get either whether it's Class A, Class B, or whatever, that kind of the fire rating that you typically see for materials, for facade materials. And it was able to pass Class A.
Nice.
Yeah, that was a very exciting day.
That's fascinating. Yeah. And Are you working, this isn't usually in the purview of a traditional architect, are you working with biologists, botanists, other people outside the discipline of building?
Yeah, 100%. There's like a bunch of converging a bunch of different domain experts on this problem, and the company Ecovative kind of has a lot of those people in house. Mm-hmm. From their like manufacturing side, from the science and biology side, for producing that particular class of materials. And learning from them is very fascinating about the nuances to the kind of biomaterial industry, and in that particularly theirs.
It's fascinating that building can be expanded to all these other people that you wouldn't traditionally associate with creating housing or creating tall multi-story structures.
So as a potential customer, being a developer, I'm very interested in this actual implementation of new ideas. So in this case, you mentioned you are installing this new facade product on a 300 unit affordable housing project. How did this work originally? Did the developer come to you with a piece of land to Autodesk and ask what they can do? Could you tell us a little about the origin story?
Origin of this of the project is coming from an industry customer that we were working with for the last couple of years. The company is called Factory OS. They are a volumetric modular building company located out of the Bay Area in town, specifically North Bay of Vallejo, maybe if you're familiar with that area. So it's like a really interesting industrial. I think it's like a war production kind of area. So it's massive shipbuilding kind of facilities out there, and they're in one of these incredibly long, large facilities that looks like it's made for building modular construction. Anyways, if you look them up, I think it's really exciting the work that they're doing in the area. They're an incredible example, I think, of that model working at a large scale. Mm-hmm. And so their mission is to provide affordable housing to the Bay Area, and they build with stick frame, so it's a light wood framed mods. So it's all completely, most completely finished. The project that we were engaging them with is located in West Oakland. The site is called the Phoenix, so the project is actually called the Phoenix, and that's the site of the 300 unit affordable housing project. There's some more information about that in the articles that we mentioned. And so in that project that we were working with them, one of the really interesting components to that was this generative design aspect. So we were working with them to build or to test and experiment on ways to design the site such that we're balancing a bunch of different goals and metrics. These sort of trade-offs between cost, like large categories of cost, carbon, and livability, or like these kind of more human-centered design metrics. Looking at aspects of the landscape, aspects of the form of the buildings and the layout of the buildings on the site, variable and development level metrics to quickly arrive at solutions that can balance and meet those the needs of the project. And I think more interestingly, like explore the kinds of design spaces or solution spaces that is just not possible, like at the speed and skills of humans. And in that process, there's an opportunity to test and explore the implementation of better materials. So how do we to improve that carbon score? So there's we have all this what are the levers to improving this carbon score? And a humongous one of that, a humongous lever is materials, right? So not just choosing, well, there's one, you could, choosing better, current materials that exist on the market. And, really there's not a lot of good options, and it's all, locally based, but there's an opportunity to use or develop a novel material as a research opportunity. How do other people do this? How do other architects do this, or are the other engineers do this? So going through that process was really important to understand the problem and to then move the project to the next level, and getting all the way to the point where we actually making the system and making the product was
So I
very
think one
important for that.
interesting aspect is like with generative design, you're kind of exploring the boundaries of this solution space, right? You're trying to see how you can optimize all these factors, but ultimately with the existing materials we have today, you can only get so far. So it's almost that you have to explore these new avenues, these new materials in order to expand the solution space towards the direction that is even more sustainable, even more optimized for all these factors that you're looking for.
There's an area that's the fog of war or whatever that you can't even see that there's those opportunities over there. Someone has to go out there and to see at least a little bit what it might be like.
And I think especially for building material, it's so important that it gets implemented, because you might be, Brian, assessing the material, in this case a facade system, on its sustainability performance, on its aesthetics, on its durability. But then when you implement it and you go out and you put it in front of like neighbors, or you put it in front of the building department, they are probably going to give you a whole bunch of other questions and concerns that you might not have thought of, in terms about life safety, in terms of how it
Fire
affects
rating.
the natural environment. Does it ruin bird habitats, for instance, or does it improve bird habitats? Things like that. I think it's so fascinating, because we think of buildings as this closed, timed system, when in fact it's quite wicked, meaning you put forth one solution and another problem probably appears down the line. So I'm wondering actually if your customer is interested in that sort of thing. How are they sort of doing analysis of the project? How are they going to assess the quality or the performance of the project as it gets implemented?
Yeah, it's so complicated,
Yeah,
right?
Buildings are complicated.
Buildings are incredibly complicated. There's you could have the most this miracle material or whatever. Doesn't matter if everyone hates the way it looks, or something weird like that. There are so many nuances to the process. The way that we were approaching some of those more abstract parts of the problem, and I think is really important to continue to do the research on and explore, is for example, the livability. This category of livability is more like human-centric type metrics or design metrics, which have to do with the relationship of the design of the building to the neighborhood, or access to amenities or things that the community would be able to take advantage of, or program that would be giving back to the life of the neighborhood, a farmers, types of farmers markets or whatever kind of. So you can measure those things in the solutions of some of these designs, and be able to try and get ahead of, for example, the kinds of municipal reviews that you would be needing to go through a bunch of those, and taking into account even in the front. So an input to this could be what some sort of participatory type design process with the neighborhood, inviting them to be a part of the process of data collection, and being very transparent about it. That could be that's could be very important. But
And for instance, was mycelium a product, a source that you wanted to already implement before starting the project, or did mycelium come up as a result of all these processes of talking to the neighborhood group, to the customer, and then checking the sustainability scores?
The Factory Us, or the customer had gone through a lot of that process, I believe.
Mm-hmm.
And so there's and they have the Factory Us has a very sensitive, or it's very sensitive to how their projects or their work is impacting the neighborhood. Mm-hmm. Like I mentioned before, their mission is to provide affordable housing and improve the places that they build. The key components to this is that it has to not only fit into the neighborhood, it has to be complementary, amplifying the kind of the neighborhood's character, and bringing new kind of cultural opportunities or like life to the neighborhood. So yeah, being very positive, having a very positive impact. So the design of the facade was an important component to that. It can't just look like a Holiday Inn or something was dropped into their neighborhood, right? Like you don't want to feel like that kind of a fabric. So it was that opportunity to utilize this novel core material plus what's the sort of the protective shell layer of this is an FRP. FRP is a type of it's called fiber reinforced polymer. It's a composite material that is in some ways like relatively new in the building industry. It's been used a lot for other industries like the marine industry. The wind turbines are made of types of composites, FRP being one of them. But that material, it's super flexible, right? And it's, it has this kind of design freedom and flexibility that allows you to take advantage of, or that you can take advantage of and be very expressive and allow architects and designers to make a solution or to design things that have character and like adapt to the context.
So we talked a lot about kind of this one project, right? The Phoenix, and how it's this prototype for this use of this new material. So how does this scale? How does this go from this one prototype to something that is more widely used in the industry?
Scaling up new ideas in the building industry has been historically really challenging. There's so many, like we're just coming back, buildings are so complicated and have so many constraints. And, we're using materials that we're currently very familiar with because they've been around for a really long time. It's like, how long has concrete been around and steel been around? And, all these materials that are familiar to us right now. Or even new wood products take a long time to become commonplace, but we don't have that time, right? For if you're looking at the kinds of trajectories of carbon emissions, like the things that we are needing to do are really dramatic right now, and how do you accelerate the scaling up of any of these technologies? And in our case, the scaling up of the use of better materials and or like better ways of designing. So, in our case, for these kinds of like low carbon materials or newer novel materials, having people being able to access the information about these materials is the first step. It's like if you're thinking about using a material, like where do you even look, right? It's like you could probably Google it and you have like a whole page of materials of websites or something, some kind of thing that you could like filter through manually. How long is that going to take you? And then once you think you found something, is it validated? Is it credible? Does it have the certifications that me as a professional feel like I trust and understand to implement and to even suggest for use on the project?
Yeah, it seems like you would need to lower the barrier of entry in terms of the risk profile of implementing the material. But I also wonder if it's a little bit, well, it's very tricky because I imagine part of the idea of scaling sustainable materials is to provide materials that are more locally sourced, but also materials that are appropriate for that locality as well. So we've already talked about the aesthetics, but there's also the just environmental performance. Like you're not going to use the same materials in California in the Bay Area as you're going to use in the Northeast, just because of the climate itself. So I don't know if you have the answers yet, but I'm thinking that it is a huge challenge in particular. And these cultures that exist because of conditions on the ground, but also because of the way people think and interact in those places, it's probably pretty difficult to penetrate. So at least as an architect, I would like to see this sort of proof of concept. Like I would like to go to the Phoenix and touch the building and say, okay, wow, this exists. It's not just a rendering anymore.
Yeah. The more that you can enable people to use materials, like there's some threshold of doing that. The more that you can give credibility to them, so that other people can use them.
Yeah.
Nobody wants to be the guinea pig, right? I feel like Autodesk is in a very good position to make kind of impacts like that in the industry. So and do the kind of research that helps us get there.
Yeah, I actually believe it now, because at first I was thinking, why is a software company trying to build something physical? But now I understand that because it's such a difficult area to penetrate, and it is a high demanded area. We need to build better, no doubt. And I think Autodesk is actually the perfect company to start that, because of its size, scale, its influence in the industry. And I bet Factory OS, they seem to be also a very influential and powerful company in the prefab world, and trying to also respond to the need of affordable housing. And I think these two missions align perfectly in the example of the Phoenix. So I do think, showing and proving the ideas are really important. And without that, no one will take the first step, because
Yeah.
I'm not at a scale of Factory OS or any other like larger development firms. If I do something, if I invest in something, it needs to work. There is very, very small opportunities of failure. So that limits even though I want to, do many innovative stuff, that limits the opportunity for me to do that. Kudos to you. And I'm very curious on where is this project now? Like, is it somewhere close to completion? What's going on there now?
So the project is currently it's in process. Part of it is under construction. The Phoenix, what was previously a site of old steel mill, which was actually it's called. It was the Phoenix. Some kind of I think it was the Phoenix was the name of the steel company that was there. Is now under construction, so it's no longer like a big concrete pad. So that's in process, and as you know, California is a notoriously difficult place to build affordable housing. Alex, you're living with it every day. And so it's in process, and we hope that in the coming years to be able to actually go up and see and touch it. Kind of get it. I think that it's the quote that the future is already here. It's just not evenly distributed, sort of thing. That's the challenge, is to help it become more widely distributed a little bit more quickly, and this will be at least one example of it starting to do that. Yeah.
We talked a lot about the Phoenix, which is a prototype project, and its applicability and your ability to kind of scale this potentially across industry. But what's next for you, and what's next for Autodesk Research?
Yeah, so that challenge is not fully solved, right? We're still working towards solving that, and making the impact for the industry to get there. And there's still a lot of work to do. The learnings from the Phoenix and the facade system that we were working on for that project have led us to a more comprehensive or detailed understanding of that problem, and how now can you provide the data and then enable users or customers to approach materials in a similar way, or in a better way than we are currently, and taking advantage of technology like artificial intelligence to help solve these kinds of complex problems and automate a lot of the repetitive tasks that are involved in a lot of building industry, or just processes in various industries, but in the AEC industry particularly, and in for materials, understanding and how to use materials. There are a lot of those same kinds of tasks, and then augmenting the capabilities of designers and engineers to be able to take on bigger challenges like this is the next big areas that we're looking
It's
into.
really, really exciting. If our listeners want to find out more about your project or more about you and Autodesk Research, where can they go to find more?
Yeah, it would be great if anyone's interested to take a look at the Autodesk Research blog on LinkedIn. There's a Autodesk Research page that you can see any of the kind of new updates from that we publish, and there's a 3-part series of articles that will also there'll be links for this that we hope users can or listeners can read. About about this topic and this project. Yeah, that's probably the best place to go.
Awesome. Yeah, so we'll make sure to include all of those in the show notes, and some of the other things that Brian mentioned in this conversation that we didn't have time to go into. This has been another episode of the Most Modern Podcast. We hope you enjoyed our conversation around materials, and maybe you can think about mushrooms a little bit differently from today forward. Thank you again, Brian, for joining us and giving us all of these deep insights, and we'll be back with another episode soon.
Thanks for having me. Really appreciate it and enjoyed the conversation as well.
Yeah, thanks, Brian. It was great. It's really interesting. I gotta go check out this Phoenix.